Okay, hello everyone. So it's actually Jura, not Jura. My topic is like from observability to reliability based on the Datadog Firebase FullStory. So again, my name is Dominik Jura. I'm working currently at Spoton as Android architect, and hopefully after this meeting, you will learn much more about observability. So let's jump in. So our journey starts from applications, no matter if it's like mobile, like Android, iOS, or like even web, or it's just some framework provided for other applications. What actually matters for us is happiness of our clients, scalability of our systems, and stability. Then that leads to growth of our products and company. So here are some Forbes article that I found. So, have we ever entered the golden age of data? Modern enterprises are collecting, producing, and processing more data than even before. According to a February 2020 IDH survey of data professionals, average corporate data volumes are increasing by 63%. Per month, 10% of represents are even reported that their data volumes double every month. What does it mean for us? Large companies are investing heavily to transform themselves into data-driven organizations that can quickly adapt to the fast pace of a modern economy that gather huge amounts of data from customers, then process data in an attempt to personalize customers' experience, optimize business processes, and drive strategic decisions. So what is our topic? Reliability. So from our topic, it's overall consistency of a measure. A measure is said to have a high reliability if it produces similar results under consistent conditions. What that mean for us? Nowadays, we see products becoming more and more complex with new features, new reliability standards. From an engineering point of view, IT infrastructure are evolving to new patterns such as microservices, polyglot persistence, containers to decouple the big old monolith into small systems, which is optimal for product, but a little bit complicated for us engineers. The amount of available tools is also increasing drastically. There are so many platforms and different ways of empowering humans to do really cool stuff. To successfully deliver and run your product under these conditions, you need observability. So from our topic. Observability is not a new concept. Indeed, it comes from the world of engineering and control theory. As per definition, observability is a measure of how well internal state of a system can be inferred from knowledge of its external outputs. So once again, to understand what is exactly the observability, is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. How to understand that topic? It's really complex, definition is really complex. So I bring for you a human example. Let's imagine our IT system is a human body. What we can see is like a face, body, someone is smiling, someone is happy. We can measure with different instruments like a thermometer, like a temperature, or like with smartwatches, blood pressure, heart rate, how many steps we done. But what's happening to us? We are getting a fever. What most of us do, like we are taking an aspirin, and after a few hours we are feeling better. Everything seems okay. So for our analogy to the applications and observability in applications, our application is not working properly. So we get some notifications, for example, for Firebase Crashylitics that some crash happened. So what we do, we jump into, see the struct trace, based on the struct trace, try to provide some fix, then looks and everything's look okay, we release it, everything works properly. But what actually happened? The problem is not solved. The problem was exactly somewhere else. It was caused by malfunction of our liver. And after a while, we get a fever again, but we still not understand the source of the problem. Like it was fever, like it was crash. And for our analogy again, we fixed the crash, at least we thought that we fixed it, but unfortunately we have repeated crash and it's happening and happening. Here observability comes in handy. what if we have implemented the observability for each of our internal organs? Let's imagine that our brain could be like, for example, some backend service, and our lungs could be like a database that we can monitor, and like our immune system is like our service that we are authorizing things. So what is the difference between monitoring and observability? As we see with the fever example, getting a fever is just monitoring, and it's not really observability. To understand observability, so monitoring and observability are distinct concepts that depend on each other. Monitoring is action you perform to increase the observability in your system. Observability is a property out of that system, like functionality of testability. So it uses the data and insight that monitoring produces to provide a holistic understanding of your system, including its health and its performance. The observability of your system then depends partially on how well your monitoring system metrics can be interpreted and any performance indicators. Another important difference is that monitoring requires you to know what's important to monitor in advance. Observability, on other hands, lets you determine what's important by watching how the system performs over time and asking relevant questions about it. So let's bring another example to understand it even much better. A developer in your company changed some critical code path to introduce a new cool feature, like everybody of us like doing that every day. Unfortunately, this caused a malfunction in the final production function. Your well-engineered monitoring system can ensure that something is broken. In most cases, it will tell you that what is exactly broken, which is essential. So sometimes it happens that our structure is like good enough and we understand it. However, it will not give you the details. We won't understand, for example, with this liver example, where is the problem. So let's bring some real example, like that's the theory, like how we best understand the theory. So let's jump. There is a tool called Firebase for mobile developers as well for web developers, really well known. Firebase have a lot of tools like database, A/B testing, analytics, and so on. But what was interesting the most is the Crashylitics. So Crashylitics here, we get this crash, we get notifications, so we know that something is better happening for our clients. And for the purpose of this presentation, I prepare a Star Wars application, really simple. For fun of Star Wars, we can see what are the movies of Star Wars, what ships there are, which of our characters in Star Wars ride what ship. So something happened in Starship activity in line 19.5. We see some structures, but it's not really readable for us, like some composite exception, what that really means for us. Let's see what else provides us Firebase. So Firebase provides us even specific information about the device, what is the brand, how much memory we have, what is our free disk, what is our version of Android. But the crucial part here is because we actually implemented on the Star Wars application the observability pattern. And one of the observability concepts is the global keys to implement them. So we already gather information about our clients who is using this application. So we have some client ID, we have some device ID, but what's crucial for us is Datadog session ID, we'll jump to this later, and we have a FullStory URL. FullStory is another tool that I will show you right now. We have some information about user, if he's really a Star Wars fan or not really, and some location. So let's copy this FullStory URL and jump to our another observability tool that is FullStory. FullStory is a tool that can, based on what user is doing, record parts of our application. So later on, our analytics teams, developers, or even business can watch it from the beginning to the end. But what we done, we actually, when this application crashed, we gathered this information, what is exactly the session of this crash. So what we will see here when I play it, we will see exactly how our user crashed. So we can pinpoint exactly what happened. So let's play it. As you can see, there's 3 buttons, characters, movies, and ships. So user enter our application thinking what he want to pick. Let's give him some time. Okay, he picked movies. So we have some new Star Wars movies without the newest versions. Guess why? And he entered, I will pause for a moment, a ship section. And we were here to actually find the crash, but what we found out that there's another big problem, that one of our screens is completely empty. We're supposed to see here ships. So even though we are fixing one crash, our observability helps us find another one. And so we now understand that the problem is much bigger, or we have like multiple different problems. So we keep going, we jump to characters. Here our clients play a little bit with it, like check the Luke Skywalker, check the Darth Vader, then make some scrolling, looking for other characters that he's interested with. Then checking Obi-Wan Kenobi. Yeah, he had a lot of ships. Going to the Chewbacca and Han Solo. Yes, they were driving actually the same ships. And then our session stops, and we don't really see what he clicked, what happens. We see that there was some exception, and that's it. So even though we can totally reproduce the path, we still don't really see what is the actual problem. So let's jump back to our Crashylitics. And here we are reporting another of our tool that's called Datadog. And we are reporting the Datadog session. So again, let's copy this Datadog session and jump to our Datadog tool. So to show you what is actually the Datadog, here he's aggregating all the informations about users, giving us a lot of charts, mobile vitals, CPU usage, frozen frames, some session per version, different versions. We can even see all the errors that happened both in Crashylitics and here. So all of them reported. We know on what time, which day was happening. We can see if we have any regressions on the other versions. We even see, and that's really cool, what endpoints we called in this application. Here are some issues that he detected. Then we have some analytics information. So how long average session take for these Star Wars clients? So around 2 minutes. How many sessions there were? Like where are based our clients? What views they are spending the most time? And so on. But that don't really give us information. So let's go to the Log Explorer. And here on the top, we pass this session ID here. So even though we can see all the logs produced by our Star Wars application, we are now filtered by exactly this session. So we can 100 reproduce and understand what was our client journey here. So he starts from some splash screen, then go to the category screen. And in the category screen, he clicked the movies. Then he had like another different screens around. Then, as was said, he was in the Darth Vader, Luke Skywalker. Then we are here seeing some fetching another pages from the internet. So he was probably making some scrolling. So even though I don't see what he's doing, I have so well written logs that I can understand his journey. And at the end, as I said, I wasn't sure what he clicked, but actually my logs provide me exactly what he clicked, and he clicked Anakin Skywalker. So right now we can exactly pinpoint that our failure, our testers can reproduce it, check what's wrong with this Anakin Skywalker. What else I would like to show you? So here, whenever we click add the logs, we have additional informations. And actually, these informations we already seen. So that's another power of observability, because whatever is the tool, it was a FullStory, it is a Fire-based Crashylitics, it is Datadog, we're providing exactly the same informations through all of our tools. This way, we can filter out by, for example, only the fun of the Star Wars. So for example, we don't start with the Crashylitics. We were just checking logs that were like error producing. So we can as well check here sessions, what our clients were doing. So that's really cool thing that we can understand a lot just by reading logs, and that's not it, because logs is just a little part of observability. So we know that he clicked on the Anakin Skywalker, but what was exactly wrong with that? So Datadog give us another thing that are traces. So traces, in the simplified word, I will later on show you the exact definition, are our requests to the external services or like queries in database. So we can see on what exactly views, what requests he made, how long these requests take. So we can, for example, understand if our clients have, for example, internet problems, so high latency. We see the error code or like 200 good code to understand if it's okay. We see how much data is passed. So we can pinpoint, for example, the requests that are really heavy. Maybe we need to make some fixes in our application. But the last request, and then our session cut off, and to show you on the top, we pass this session, so we filter only by this session. We probably have thousands of requests every day, every hour. But we just want to check our client session, and here what happened. He actually made 404 requests, and that's why he's failing. So our application, and that's the exact reason, is not handling well errors that's happening on the requests. And here there are traces, completely different tool, but what I want to show you is that here we as well providing the same informations. So we can even start from tracing. We see like 500 errors. Okay, let's understand how our clients achieve these errors. So we can go to FullStory. We can go back to the logs. We can have associated logs with these traces. We see exactly, we can see the errors if we have correct information about that. Okay, let's go back to our applications. So that was our Star Wars example. So in observability, we can divide it to 3 different pillars: logs and events, tracing, and metrics. So what are our logs? Infrastructure is always producing logs. It doesn't matter if they are warning, info, error, like critical logs. They were always happening. With growing complex distributed systems, it's essential that you keep an eye on your logs. Doing so may be very tiring if you don't have the right infrastructure to ingest, elaborate, and show logs to you. For that reason, there are multiple tools to help you gather these logs, like a Datadog that I showed recently, that have a really smart management. So here as well, I provided for you some tips, advices, how we can collect our logs. So first of all, understand your logs and events, so you know whenever you read it, you know what they mean, where they happen in your application. Don't overproduce them. So many services don't overproduce them. So it's really hard to find crucial logs. Try to log the most crucial things in the system. And for every log, events, try to add important attributes. So as I show you, like, for example, our client's ID, maybe some crucial parts, maybe IDs to different sessions from the different tools. Here is the example of how logs can look like. So that was our Star Wars example. So we have an exact date, exact service, content. So another of our pillars is called tracing. So what is this distributed tracing? Distributed tracing is a method of tracking application requests as they flow from front-end devices to the back-end services and databases. Developers can use distributed tracing to troubleshoot requests that exhibit high latency of errors. A trace represents the entire execution path of the request, and each span in the trace represent a single unit of work during the journey, such as like API call or database query. Like, to understand this better, because this definition is really complex, let's make another analogy to our human. So imagine that we are eating a poison apple. We start with a mouth, then we go through the throat, and finally go to our stomach. So each trace will give us information what happened with the apple, how it was proceeded. Then we can pinpoint the bottlenecks of our systems. So for example, in the throat, there was something bad happen and it never go to the stomach. Or in the stomach, there was where the poison started working. And now we know the error. Now we know that not like a front-end application, but one of our microservices is failing. So here, like, is a Datadog example. There are, as I said, like many other tools, but all of them, like treating traces, are really the same. So trace here, if we look, have a start point, and it's starting in some shipping cart. Then he calling some internal things. Then he calling some out service, going to Postgres, so calling some database in out service, going back, so it's probably authorized, then making some little work, jumping to another section of our application, of our applications. So this is the spans, these rectangular spans. Spans with the same service are the same color, with different service are different colors. Then it's making some work in a different service, making quick request, but doing like getting back information immediately. And this one is doing in the parallel. Then going to our another field of our service to payments, then making a payment, then going in this payment, making some work, going forward, then calling another microservice probably, making some operations, and so on and so on. We can see how long each of these operations take time, and our whole request take time about 260 milliseconds. So even from these graphs and this like one trace with a multiple spans, we can already understand if there are any bottlenecks, maybe why this like service is taking so much time. Maybe we need some optimization on the database and so on. On the trace, as I said, we have attacks, we can have associated logs, we can have errors, we can even see if like this microservice, what are the AWS profiling there, how much memory it have when this request goes through. So that's our power of observability in the tracing. And we have our third pillar that called metrics. So what is metric? Metric is a numerical value that can track anything about your environment over a time. What are metrics useful then? Metrics provide an overall picture of system. You can use them to assess the health of environment at a glance. Visualize how quickly users are loading your website or the average memory consumption of your servers. Once you identify a problem, you can use logs and tracing to further troubleshoot. In addition, metrics can help you adjust the scale of environment to meet the demand from your customers. Knowing exactly how much you need to consume in resource can help you save money and improve the performance. So I will make another analogy to the human. I would like treating metrics as the vitals. So it could be like our temperature, heart rate, blood pressure, and so like even steps every day, or like how many sports we are doing every day. So there are values in our system. Here is one more advice. Prepare metrics that are important not only from developer's perspective, but as well from product analytics point of view. So don't think about observability that I am a developer, I want to implement observability to understand the problems. Actually, observability is concept for all the people like QA, DevOps, engineering, business, and analytics. So based on these three pillars, there are some tools that help us build our observability. One of these tools is called monitors. So what are the monitors? When we have a metrics, let's say, for example, how many requests failing in our system, and our monitor is a tool that if this metric will go above 5%, so a lot of our requests are failing, we'll get an alert. Another example, what if our container is using too much memory? So let's set like a monitor for 90% of memory usage. If it triggers, then we have an alert and we know that. So here are some advices. Find value for your monitor to trigger. Keep in mind that you don't need to find it at the beginning. You need to observe, understand what are your values, maybe change them several times, and then find the perfect value for you. Send alerts to mail, Slack, Microsoft Teams, or SMS. So whenever this happens, and that can be crucial for our clients, something's failing, maybe my whole microservice is down. Let's have an alert immediately to understand it. Specify priority danger level, P1, P2, P3. For example, if our request failing like 50% or are like 100%, so whole service is down, we need to like priority 1. We need to understand it, address it immediately. Maybe even call to developer on the on-call duty. Or like we can have some information monitors, like if we exceed some number of clients, then we want to have just a monitor alerting us that in some point of time we should, for example, have a much bigger AWS servers. So that's our monitors. Another one is called synthetic tests, also known as automation tests. So build your automation tests for your API. So whenever you're calling some endpoint with any arguments, you actually can actually know what is the response. So build automation tests over that. You can build automation tests for like test browsers, mobile, Android, iOS, and run them, for example, each night, every hour, depending on how crucial it's for is. And in the observability here, it's really nice tool, because before your clients start complaining that server is down or something is not working, actually our test will find it much faster. For example, it will run in the morning, so we're going to the job and see, okay, our tests are failing. We can fix it before even our clients get up. So that's the synthetic tests. And the dashboard is another tool. So we have all these pillars, all these informations, and like that's a lot, and we need to check a lot of things. But here is a helpful thing, dashboard. So let's aggregate all this information in one place so we can, at a glance, understand what are the problems, if we are okay, if we are exceeding some metrics. So here I have as well for you some advices. Use percentage metrics to understand scope of the problem. So let's imagine our application have 2,000 failing requests. Is it bad or not? So it's not really giving us the information because our application is doing billion requests and it's like 0.0.1%. So rather use percentage than the values one. Use colors like green, red, yellow. So for example, we have some warning, let's mark them yellow. If we have some crucial monitors that are failing, mark them red. That give us attention so we can immediately see what is the problem. Think about metrics like latency, error rate, system health check, memory usage, and so on. So here's as well another example of dashboards. Keep in mind that you are building dashboard for your product. You know yourself what is crucial for your product, what is important for your product. You can use pie chart, you can use value diagrams, you can use any chart that suits your purpose that you can understand immediately what's going on. So that's the theory, but how to implement this observability? To achieve observability, you need proper tooling of your system and apps to collect the appropriated data. You can make an observability system by building your own tools using open source software or building like a commercial observability solution, as we use Datadog. Typically, are there 4 components involved in implementing observability. So first one, instrumentation. There are measuring tools that collect telemetry data from a container, service, application, host, or any other component of your system, enabling visibility across your entire infrastructure. Second one is data correlation. The telemetry data collect from across your system in process and correlate, which creates context and enables automation time series visualization. So our fever example, we won't know what this fever is, but with the correct data correlation, we will understand that the problem is in our liver. Another one is incident responses. Test automation technologies are intended to get data about outages to the right people and teams based on the on-call schedules and technical skills. So our monitor example, that we will be immediately inform any messages way path. And the last one, AAOPS. Machine learning models are used to automatically aggregate, correlate, and prioritize incidence data, allowing you to filter out alerts, noises, detect issues that can impact the system, and accelerate incident responses when they do. So what are the criteria for good observability tools? So we are now know how to build it, but maybe want to pick some commercial things. So regardless of whatever you choose to build your own or use like open source or commercial solution, all observability tools should integrate with current tools. Like if our observability, like we have an Angular framework or we are writing in Python. So we need to make sure that whatever tool we use, it at least can support our systems. We won't write everything from scratch if we are buying commercial solution. Be user-friendly. If observability tools are hard to learn, hard to use, it's hard for us to understand and hard for us to achieve whole observability pattern. Supply real-time data. Your observability tools should the relevant insights via dashboard, reports, queries in real time, so we understand immediately the problem. Support modern event handling techniques. Effective observability tools should be able to collect all relevant information from across your stacks, technologies, and operation environments. Separate value signals like noises and add enough context so the teams can address it. Visualize aggregate data. So as I already showed you on the dashboards, we want to have nice tools that allow us to make a graph or even different graphs, tables, pie charts, maybe some values, also nice coloring or grouping them together. Provide context. When an incident happens, your tools should provide enough context for you to understand how your system performs, has changed over time, how the change relates to other changes in the system, in the scope of the issue, and any dependencies of the affected service and component. Use machine learning. Your tools should include machine learning models that automate data processing and curation so you can detect and respond to anomalies and other security incidents faster. So for machine learning, I will give you another example. As you saw lying on this dashboard and so on, we can have, for example, error rate in Android application that have some peaks in the graphs. And let's use here machine learning correlation, so both of these good observability tools. And what we find out that our artificial intelligence go through all of the charts and all of the metrics that happen exactly in this time of this error failing, and he will give us 5 different graphs, and that will be exactly similar. And one of the graphs could be like database queries failing, or another graph could be microservice requests are failing. So even though we have graphs, we have some errors, with nice artificial intelligence and correlation, we'll understand immediately where are these issues. Deliver business value. Make sure you're evaluating your observability against metrics important to use business, like deployment speeds, system stability, and customer experience, and as well cost. Keep in mind, if you are using commercial solution, what is the cost? How much information we are providing there? So what tools are available like commercial? There are like much more. I like just pointed that one that I like the most. So Datadog, really nice, supporting distributed tracing, logs, metrics, dashboards, monitors, synthetic tests, and many more. Have really nice artificial intelligence, can point us anomalies. So even though from our metrics everything can look like okay, but AI can find out anomaly that even though it look okay, we could actually have huge problems. That's really a cool thing. So Firebase, as I said, really nice tool that aggregating as well many things like analytics, Crashylitics, database, A/B testing, and so on. And at the bottom, some analytics tools like FullStory, so we can record what is happening, whatever is mobile or web, heap, and other like analytics tool and amplitude. So who can use the observability? Individual developers and software engineers benefit from the observability because of the visibility it provides into their entire architecture. From third-party apps and services to their own. This not only enables them to more easily fix, eventually prevent problems, it also helps understand system performance. So I like to treat developers as doctors for our human analogy. DevOps, like another one, like DevOps have all this infrastructure, Kubernetes, containers, Dockers. They want to understand all the metrics that are happening around, if everything is okay, if they need like new deployment. Analytics. So analytics in our analogy could be like our mental health. Like if we provide nice observability of our application, an analytics team will look on that. We can understand maybe we have some UX flow, maybe there are screens that nobody is going to. So they are like kind of our, I don't know, psychologists or our therapists and help our mental health. QA team. Like QA team, I like to utilize as like a medical examination, so they can make scans of our brain, scans of our body, maybe measure our temperature, measure our blood pressure. And this way, they will find out before even using the application that something is wrong. And the business, however, might benefit the most. Observability allows you to make changes to your apps and services without compromising the stability of your system by giving the tools to understand what's working and what's not, pinpointing an issue that crop up and quickly improve or resolve them. New features combined with less downtime translate to happier customers, and that's our end goal. So thank you for the presentation. My name again is Dominik Jura. I am Android architect at Spoton. And last analogy for you for end of this presentation, having all this in mind, let's build just better society, because human is one person, but we have whole society, so let's keep them healthy, let's keep them checked, so this way we can build better products. Thank you. Are there any questions, please?
Are there any cons of having multiple analytics systems in one application?
Yeah, definitely. Like, keep in mind each of these tools, if you are reporting them, is like taking some memory, can also slow down our application. But what happened with modern observability tools like Amplitude, Heap, Google Analytics, Datadog, that they are actually much more smarter, and they are checking what is the CPU usage, what is the our network, if it's healthy or not. And then if they see that the application is not doing much, then they trying to send batch informations. So even though we have multiple analytics tools or like Datadog observability tools, they're so advanced that they're trying not to overheat our application.
You showed us Datadog,
Yeah.
which seems like a huge tool. And there are traces, dashboards, logs, and all this stuff that seems like a lot of setting up. Where we should start, like if we don't have any of it, like to like have something to start with?
Yeah, really good question. So we need to start somewhere. I would suggest starting what we already have. All of our applications are already producing logs. Let's start with basic things that we want to observe. So let's start with logs. When we add logs, let's start with tracing. Tracing, as you already learned, are powerful tool when our order services like microservices databases are in the flow of the trace. So let's ask our backend colleagues, can you implement Datadog for us for the traces? And then when we have this basic information, so we start from logs, traces, and just simple metrics like how many users came to our application, how many crashes we have, then let's slowly build up feature by feature our whole observability. Okay, I don't see any more questions, so thank you again very much. Hopefully you learn about observability and you can go home next day to the work and ask your business to implement it in your products. Thank you.